Hello, Assalamualaikum, and very good morning. So my name is Muhammad Nafi Bashir from College Metropolitan. I will present about the effect of Unground palm oil fuel ash on acid resistance of our pump shell lightweight aggregate concretes. So this is my group members, Dr. Safwan, Dr. Karinisa, Muhaiza Ghazali, and Dr. Ahmad Mukhtar Bashir Budia. So in this topic, the introduction is first I will show you the concrete material issue. So we use a lot of concrete material in our development, not in Malaysia but in the entire world. So globally, we use 20 billion tons and 9 billion tons of aggregates uh, to our development. So the escalating of concrete consumption is expected in the future. Thus, could disturb the environment as both cement and aggregate production consume substantial amount of non-renewable material. In the concrete, 70 to 80% uh, volume come from the aggregates, and globally the usage is estimated to rise up about 51.79 billion tons in 2019. So, occurring activities and sand mining disrupt our flora and fauna, habitats, and alter the green scenery, and has disable impacts to the surrounding. So, parts of palm oil industry issue. Malaysia is second largest producer of palm oil. So the increase of palm oil shell and palm oil fuel ash, as we state as a waste, generated from the sponsoring palm oil industry, pose threat to our environment when disposed. So where we dispose? We dispose nearly to the palm oil mill, and when we dispose, we need a large area to dispose. So the disposal also use a large area and such as POFA. POFA is ash, so ash is very bad for the air and be easy to blow by the wind, thus affecting the air quality that can affect the health of youngster and senior citizen. That's why these two things can be used and recycled for a concrete replacement material. Why? Because we want to save our environment and we can have a green material production of that. So this is experimental program. We use the OPC cement, sand, Unground POFA, water, and super fertilizer. And POFA I get from the Boston mill from Chini, and OPS we get from Maran, the Felda mill. And other material come from the supplier of local suppliers. Uh, the try mix that we use is in grade 30 and used as a reference specimen. And specimen was subject to type of curing, air and water curing up to 38 days before testing. So we follow the composite strength testing from British standard, and the acid resistant testing. We follow the testing procedure of MELA. So this is the result and discussion. Uh, from the result, we can say 10% versus 20% replacement of sand. So 10% get par of our sample specimen, which is 30 something of megapascal, rather than 20%. So why it compares 2 point, which is one is workability. When we use a more replacement, it's hard to compare, it's hard to mix. So the concrete have more pores in 30% rather than 10%. And this trend is similar to the other researcher is Ahmad Zahawi that used the integrated waste on his mixings. The air cure concrete specimen exhibit higher mass loss rather than water cure concrete specimen. Then, because the reaction between acid and calcium hydroxide produce soluble end products, we could have seeped away from the concrete internal structure and in turn initiate the removal of fine aggregate creating pores, resulting in mass reduction. So OPS concrete with 10% of unground POFA experience the least mass loss compared to the plain concrete in box mix. So we can say more pores, less strength. So use the higher quantity of unground POFA at 20%, you got the higher mass loss. And unground POFA water cured specimen experience the least strength loss, signifying their superior durability. Why? It's about density. This could be ascribed to the denser arrangement of the concrete microstructure, owing to the improved hydration process and pozzolanic effect in a moist environment. So water is very helping in the pozzolanic effect to make the concrete strength higher. And the actual concrete specimen exhibit higher mass loss failure throughout the emission period when compared to the water cured ones. So we can say the OPS concrete with 10% open power influence the least mass loss compared to the plain concrete in both mix. So in the conclusion, enhanced acid resistant or water cured OPS concrete is attained through the beneficial effect of pozzolanic activity when blended with 10% of POFA. So it ingests calcium hydroxide, which would otherwise be leached away by acid, create a well-packed internal structure with the lowest mass reduction and least strength restoration value. And yeah, you can say it is success. And when we use this, we can save our environment. Thank you.